Hello, I will present the work entitled The Propagation of Sound and 3D Study of Picea Abies Good. This work has as a main objective to evaluate the propagation of sound and to correlate with the anatomical 3D microstructure of good in order to determine the capacity of have a better sound for production of different kind of instruments like violins, violas, cellos, etc. So this work is main working by evaluating the velocity by an ultrasound using samples with size of 3 by 3 by 3 centimeters cubics. So we obtain from that the Young modulus calculated based on the velocity of transmission of sound throughout the good samples. On the other way, we analyze the anatomical microstructure by X-ray computer microtomography, and we can have a detail of the whole microstructure that compose the good. So we analyze three different directions. The main direction of the good, that is radial, tangential, and longitudinal direction. In order to complete our analysis, we run numerical fluid simulation through the real microstructure of wood by using Abies software. The result shows that we have the analysis in two different anatomical composition of good, like late good and early good. This change because the fibers have a largest thickness when we have one on another conditions. So we measure different anatomical characteristics of the good, like cell wall density, cell wall volume fraction, thickness, diameter, and lumen volume fraction. For late good, we found that the density is higher than in early good. This is consistent with the cell wall density and when the volume fraction of the cell. The thickness is also almost a half when for early good in comparison with late good. So the lumen volume fraction is 37 and 75. So it's the opposite when we have the early good. So we can notice that the acoustic velocity is higher when we are measuring in the longitudinal direction. This is because the lumens are oriented in this direction. This also induces a higher Young modulus obtained for the longitudinal direction. So this is consistent with the mechanical properties reported for such kind of good species. On the other hand, we show that the path flow lines are straight in the longitudinal direction. On the contrary, when we are analyzing the radial direction or the tangential direction, we found that the trajectory of the flow lines are more tortuous. This means that the fluids are more complex to pass throughout the good. This is consistent with the measurement obtained by acoustic velocity. We also are obtaining that the radial direction has the more complex path to pass the fluid through it, as we can observe in here. So in the other case, we observe that the velocity is higher when we are in the longitudinal direction. The red color shows the higher velocity, and the blue is lowest velocity for all samples. We can also notice that the trajectory of fluids are higher when they are passing through the void spaces that are related to the porosity of the good. So we conclude that the greater fluidity is in the vacuum and in the longitudinal direction. So we can also conclude that the best condition for the propagation of sound or fluids through the Picea good are when we have more void spaces, which is the early good. So we can propose that early good will be best for the sound or acoustic sound in the different musical instruments. So thank you very much.